All right, so here we go. Now we're going to do grams, and let's see how this works. So we discussed now the mole-to-mole relationship comes from the balanced equation, but now we're dealing with grams as well. And whenever you need to do grams, you should look at the thing that has grams, and that is the periodic table. And the periodic table means this will require more work if you have a gram to mole relationship. The mole to mole we just did were pretty easy. So now with the gram to mole, it should be a little more work. So our given here is 270 grams of oxygen, and it wants to know how many moles of aluminum. So our answer will be moles of aluminum. So the first thing we got to do then is cancel grams of oxygen. And where do you go? Well, you can't go right from grams of oxygen to moles of aluminum. There is no relationship directly between those two. But with the periodic table, we can go from grams of oxygen to moles of oxygen. And from there, we can go mole to mole. So the gram to mole relationship, this comes from the periodic table. And if you look on the periodic table, you will see that oxygen is right here, and it weighs 16. This is taking too long. So there's a 15.999. So it's going to be 16 per. So the start from current slide. There we go. It's going to take way too long. All right. So we have 16 times 2 for O2. Oops. For O2. O2 is 16 times, so that's 32. So that's 32 grams in 1 mole. And now we got to go from moles of O2 to moles of aluminum. And we get that from this balanced equation. So you can see here there's 4 moles of aluminum for every 3 moles of oxygen. So we multiply the tops, 270 times 1 times 4, divide by the bottoms, 32 and 3, and we get 11.25 moles of aluminum. So let's jump now to question 4, where we have the balanced equation, the combustion of propane. So C3H8 plus oxygen makes water and carbon dioxide. We're given 94.16 grams of propane and excess oxygen. Remember, the limiting reagent has to be one of your starting materials. And if we have excess of this, that means that C3H8 is our limiting reagent. We need moles of water vapor. So we want moles H2O. So we start with our 94.16 grams C3H8. We want moles of water when we're done. The first thing we do is we got to get rid of grams C3H8, and we got to go to moles C3H8, because we can't go right to moles of water. We have to first do C3H8. And this gram to mole relationship comes from the periodic table. And if we look at carbon, there are 3 carbons. Each one weighs 12. That gives us 36. And we look at hydrogen, there are 8 hydrogens. Each one weighs 1, so that's 8. Add those up, we get 44. So there's 44 grams of C3H8. And since it's from the periodic table, that's in 1 mole. 1. That's a big one. 1 mole of C3H8. Now we got to go, that gets rid of the grams. We need to go from moles C3H8 to moles of water. You can hear my daughter playing in the background. C3H8 has a coefficient of, there is no coefficient. It's an understood 1. We wouldn't have written it if there wasn't some in there. Moles of water, coefficient is 4. So now we multiply 94.16 times 1 times 4 divided by 44. And we get an answer of, in this case, number 4. We're going to get an answer of 8.56 moles of water. So that's 94.16 times 4 divided by 44. All right, so now the harder ones, these limiting reagent where you have 2 sets. So we're given 440 grams of propane, and we are given 320 grams of oxygen. and we want to see how many moles of carbon dioxide we need. If it asks for grams, you'd have to go all the way to grams, but if it's just asking which is the limiting reagent, you can stop at moles. It's still a quantity. So we're given 440 grams of C3H8, and we want to go to moles of CO2. The first step comes from the periodic table. Grams to moles of C3H8 is from the periodic table. And if we look up, that was 44 grams in 1 mole, 3 times 12 for the carbon, and 8 times 1 for the hydrogen. So it's 44 grams in 1 mole. That gets rid of our grams. Now we need to go from moles C3H8 to moles of CO2. And that relationship comes from the balanced equation. So we need moles of C3H8, understood 1, since there's no coefficient here. And the moles of CO2 is right there as a 3. So you multiply the tops, the 440 times 1 times 3, divide by the bottoms, 44, and you get 30 moles of CO2. And now we do it all over again with the O2. So let's make O2 in blue. So you have 320 grams of O2. You get from the periodic table the relationship of 32 grams of O2 in 1 mole of O2. And then you get from the balanced equation that there are 5 moles of O2 in every 3 moles of CO2. Multiply the tops, divide by the bottoms, and you should get 6 moles of CO2. And since this is less, that means that this is limiting. The starting material that's connected to that is limiting. That is that, and hopefully we can stop this now. Here we go.